All right, let's do a brief bit of arithmetic here after reading the story, The Library of Babel by Jorge Borja. So he describes this library where all the rooms are hexagons. And each room, he doesn't describe where the doors are. They might be like this. But the other four walls have bookcases on them, right? And each of these walls has a bookcase which has 5 shelves and 32 books per shelf. Now this is enough information to figure out how many books is stored in a hexagon, right? We could, look at that. So I could do 5 times 32, that's 160 books per wall, times 4, and I'd get 640 books per hexagonal room. But how many hexagons are there? Well, so he gives us some other information which is handy. He also tells us, right, that a typical book in the library, in fact, all the books in the library are the same, right? He doesn't comment about what the titles are or the markings on the spine, but he says each one of these books has the same number of pages. And by he, I mean the narrator in the story. So each of the books is 410 pages, and each one of the pages has 40 lines of text, and each one of the lines of text is 80 characters long, and there are 25 characters to choose from. This is kind of weird, I'm sure, to imagine. It doesn't include upper and lowercase, it doesn't include lots of punctuation or numerals. It just includes 25 symbols that can be used on each page. So every one of these books is the same format. And in the story, the narrator says the theory of the library is that it has all such books. So this is key. All such books are in the library. So, what can we say about that? Let's figure out how many different books you could have using this idea. And here's the idea. How many choices do you have if you imagine starting a new book? Here's one page. How many choices do you have for the first character? You may have 25 choices to pick from. How many choices for the next one? We have 25 more choices. You can repeat characters. How many choices for the next one? Well, it's 25. How many choices for the next one? Well, it's 25. And so on. The first line has 80 characters, and they could all be the same or they could be different. So the number of different first lines of the book are 80 copies of 25. So that would be 25 to the 80th power. That's a lot. What does our handy-dandy calculator say? 25 to the 80th power, too big. It's already too big for my calculator to handle. Oh. That's just the first line. But there are 40 lines on a page. So I would keep multiplying this over and over and over again. So how many characters are on a page? There's 80 times 40. That's 3,200 characters per page. So, how many possible first pages are there? 25 to the power of 3,200. Wow! But there are 410 pages in the book. So, how many possible characters, strings, can you have in this book? So, well, there's 80 characters per line, times 40 lines, times 410 pages. Right? So, 80 times 40 times 410 gives you 1,312,000. So the number of books is 25 to that power. This is an enormous number. For comparison, consider a smaller number, right? So this number is bigger than 10 to the 1,312,000. It's bigger. This number is easy because when you multiply by tens, you just add zeros. This number has 1,312,000 digits. This one has more. This number is so big, it wouldn't fit in a book in this hypothetical library. This is an enormous number. It's huge. But it's still less than infinity. We'll talk about in class how big this number is or try to wrap our head around it. It's a huge number. One additional thing for you to puzzle about, and this adds a spooky element to the story, because each of these hexagons only has 2 doors. If you like the story, if you like the spooky element of people screaming and being thrown over railings and all that sort of stuff, consider the following. Imagine that you pick some assignment of doors. Well, pick a door over here. It doesn't matter. It could be right here. There are those 2 doors. Pick a door over here. It could be those 2 doors. Pick a door right here. It could be that. Now, here's something that's kind of interesting. If you're a person over here, you can easily get to any one of these rooms, really easily. But notice that in this arrangement, you couldn't get anywhere else. You're trapped. Only 2 doors, so this can't be the way it's constructed. Also notice that if you're in this room or this room, and there's somebody being thrown over the railing over here, you can hear them scream, but you can't get there. And if you try other arrangements of doors, say something like this, well, now you can't get to this room. And if you try something like this, then this is impossible because there's no way for this middle one to have another door. If you play with this, you'll find that it's devilishly difficult. In fact, there's some mathematical theorems about the fact that there are large portions of this library that are arbitrarily close together, but arbitrarily difficult to get to. Sort of a haunting idea, I think. Think about this stuff. We will chat in class.